Primary versus secondary storage, beginner level, introduction. Primary and secondary storage are two main types of memory used in a computer system. They work together to store data, process information, run programs. The key difference is primary storage means temporary and fast. Secondary storage means permanent and larger. Understanding this difference is essential for learning how computers manage data. This topic helps beginners understand types of storage, differences between memory and storage, how data flows in a system, performance versus capacity trade-offs. What is primary storage? Primary storage is the memory used by the CPU to store data temporarily while processing. In simple words, primary storage is short-term memory used during execution. Examples: RAM, cache. Features: very fast, volatile, data lost when power is off, directly accessed by CPU. What is secondary storage? Secondary storage is used to store data permanently. In simple words, secondary storage equals long-term storage for files and programs. Examples: HDD, SSD, USB drives. Features: non-volatile, large capacity, slower than primary storage. Why? Both are important. Both types are essential because primary storage enables fast processing. Secondary storage enables permanent data storage. Together, they balance speed and capacity. Without primary storage, programs cannot run efficiently. Without secondary storage, data cannot be saved permanently. Primary versus secondary storage overview. Feature: primary storage, secondary storage. Purpose: temporary processing, permanent storage. Speed: very fast, slower. Volatility: volatile, non-volatile. Capacity: smaller, larger. Examples: RAM, cache, HDD, SSD. Primary storage examples. Primary storage includes RAM stores active programs, cache speeds up CPU operations. Data equals 1, 2, 3, stored in RAM during execution. Secondary storage examples. Secondary storage includes HDD, large capacity SSD, faster performance, USB drives, portable storage. Example: file equals document.txt, stored permanently. How data moves between them. Step 1. Data stored in secondary storage. File equals program.py. Step 2. Loaded into primary storage. RAM data equals file. Step 3. CPU processes data. Result equals RAM data dot upper. Step 4. Save back to secondary storage. File equals result. Simple example: hello world hashtag stored in disk. Load into RAM data equals file. Hashtag process result equals data dot upper. Hash save back file equals result. Print file. Key differences explained. Speed: primary means fast, nanoseconds. Secondary means slower, milliseconds. Capacity: primary means limited, gigabytes. Secondary means large, T-bytes. Usage: primary means running programs. Secondary means storing data. Real-life analogy. Think of it like studying. Primary storage means your working desk, temporary work. Secondary storage means your bookshelf, long-term storage. Use case example: task equals run program. If task equals run program, print. Load from storage to RAM, print. Execute using CPU. Full menu-based simulation, Python. Def load data. Return input, enter file name. Def process data, data. Return data upper. Def save data, data. Print saved, data. While true, print. N1, load data. Secondary means primary. Print. 2, process data. CPU. Print. Save data. Primary means secondary. Print. Exit. Choice equals input. Enter choice. If choice equals 1, data equals load data. Elif choice equals 2, data equals process data, data. Elif choice equals 3, save data, data. elif choice equals 4, break, else print invalid choice. Concepts learned from primary versus secondary storage. Memory versus storage difference. Data flow in a computer. Speed versus capacity trade-off. Temporary versus permanent storage. Role of CPU in data processing. Ways to improve knowledge. Monitor RAM usage. Upgrade to SSD. Learn memory hierarchy. Study cache optimization. Explore file systems. Common mistakes beginners make. X. Confusing RAM with storage. X. Thinking more storage improves speed. X. Ignoring memory limitations. X. Not understanding data flow. Where these are used. Used in computers and laptops, servers, smartphones, cloud systems, gaming systems. Simple definition. Primary storage, temporary memory used during processing. Secondary storage, permanent memory used to store data long-term. Final summary. Primary and secondary storage work together to make computers efficient. Primary storage provides check, speed, fast access. Secondary storage provides capacity, capital, permanent storage. Understanding this helps you optimize performance and storage management.